In this video, we're going to go over the materials that you're going to be using for your human sensor projects. First, I'm going to go over the materials that you'll use across your projects, both the e-bracelet and the human sensor projects. Okay, I have my scissors, a very handy tool. I have embroidery floss, okay, which is just a type of thick thread that you can use to create stitched designs. It is not conductive. I have a few assorted colors of felt. Okay, these are pretty small pieces. They are perfect for cutting out various shapes in order to decorate both of your projects. And I also have a large piece of felt. In this project, instead of creating a human sensor on like a pre-existing item, such as a bag or a stuffed animal or a hoodie, you could create some sort of new object. You could invent something using this felt. Okay, so these are the items that you could use across your projects. Now I'll go ahead and go into what's in the human sensor kit. Okay, something that stands out to me, of course, is the Circuit Playground Express. This is our microcontroller. It's a small computer that is all on one board, okay? You can see there are a lot of holes around it. Those holes are called pins, and we'll be using our conductive thread to sew into these pins in order to create circuits that this microcontroller will be able to control. The Circuit Playground Express, the microcontroller, will be powered by a lithium-ion battery. Here is the battery. It is rechargeable, so don't throw it away when it runs out of juice. Okay, when your Circuit Playground Express is plugged in, it will be powered when it's plugged into your computer. This battery is to power it when it is not plugged in to your computer. Right here I have a micro USB cord. Okay, this is how we are going to download our code from our computer to our microcontroller. So we're going to be using the USB side to plug into the computer and the micro USB side to plug into the Circuit Playground Express. I'll go ahead and demonstrate that because I want it to be very clear. So here I have my Circuit Playground Express. This silver port up here, that is for the micro USB. So the micro USB plugs into there. And when it's like this, I'll be able to plug the USB into my computer, and my computer will be able to communicate to the microcontroller. This black port, it's hard to see, is for the lithium-ion battery. Okay. Here I have my conductive thread. They are in little clear plastic spools. These spools are designed for use with sewing machines, but we're going to be using them to hand sew our projects, okay? If you remember from the last video, the conductive thread is conductive because it is, fibers we normally use, like cotton and polyester, blended with metal fibers so that it can carry an electrical current. Okay, here I have an assortment of sewable LEDs. Okay, right now they are all connected to each other. It's a strip of them. I can read on the back what colors they are. So if I were to read these, it looks like I have white, pink, red, yellow, green, blue, and white. So I guess there were 2 whites in there. If your LEDs come in this way, what you'll want to do is separate them carefully. I have found that the best way to separate these LEDs is to take them and to very carefully with like the tip of your thumb or thumbnail, press down, creating a lever. Okay, I don't know if you can see this. I'm pressing down in between the one closest to the table and the next one. So I'm right here pressing down, and that'll give me one of them and I just kind of remove it off to the side. And I can do that with all of my LEDs to separate them. Okay, they shouldn't be too hard to separate. If you're having trouble, you might be able to use a household item like pliers to separate them, but be very careful that you don't damage the components. Before I put these away, I should mention that different colors have different resistance. What that means is it's harder for some of these colors to light up than others. And if you put components with different amounts of resistance into the same parallel circuit, the electricity is lazy and it's going to choose the path of least resistance. So for example, if I were to have some red LEDs in the same parallel circuit as some blue LEDs, okay? Blue has very high resistance, red has very low resistance, and generally speaking, the resistance goes kind of in color order, you know, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, with red being the least resistance and violet being the most resistance. So blue is gonna have more resistance than red. When I put blue and red LEDs together in the same circuit, the red is going to show very well because it's low resistance and a lot of the electricity is going to choose to go that path, but the blue being higher resistance is not going to show as brightly. So that is something to consider when working with these. I'll go ahead and put these back into the baggie. In the human sensor project instructions, I believe your Sobel LEDs are each going to be on their own circuit, which means it'll probably be okay to mix colors. But if you're to put multiple LEDs into the same, programmed by the same pin, because you want to be fancy, you might run into those problems, which is why I mention it. Looks like the next component I have here is a battery charger for my LiPo battery. I'll go ahead and open it up, okay? Here's that battery charger. It has those same 2 ports that the Circuit Playground Express has. The silver port is for the micro USB side of your micro USB cable, and the black port is for your LiPo battery. When you plug this in, it will charge your LiPo battery. If your LiPo battery was attached to your CPX when it's plugged in, the CPX is not designed to charge a battery while it's plugged in. I wish it had that feature. That would be a great feature, but it does not. So to compensate, we have these battery chargers, which we can use to charge our batteries when they run out of juice. The last 2 items I'm seeing in my kit, I have a square of foil. On my square of foil, on the back is paper. That's because this aluminum foil has been treated with iron-on adhesive. What that means is this paper had a side of it that had a heat-activated glue. And we put that side with the heat-activated glue face up, and we put the foil on top of it, and then we used an iron so that that glue would stick to this foil. When you work on your project, all you have to do is remove the paper, and the glue is now stuck to the foil. When you want to attach it to your project, you'll use a clothes iron, and you'll be activating it with heat again with that clothes iron. And that heat will let the foil and the adhesive now stick to the fabric-based project that you are doing. It looks like my needle is also attached to my foil patch. I'll just slip that out. I have a needle, okay? Again, it'll be either your best friend or your worst enemy. We want to make sure, since it is pointy, that we don't just let it lie loose in our project bag. So whenever we're done working for the day, it's always best to kind of put it into something. Here I can put it into my foil sensor to keep it from poking anything very easily. I could also use one of these felt pieces, okay, just stabbing it through and back so that it's not going to bother me as much as a loose needle could. Of course, this could still poke me, but it's less of a danger than if it was just floating around in my bag. Those are all of the components for your human sensor project. You'll also be using a computer in order to communicate with your Circuit Playground Express. If you have questions, you can ask one of your instructors directly, or you can ask your question on one of our troubleshooting discussion boards. That's a place where you can ask questions and we can give you answers, hopefully in a quick amount of time. Thank you.